Yes. Hi everyone, I am SS Kiran. Okay, I would like to discuss about the basic experiment of CC amplifier in the basic electronics course. Okay, in this experiment, to measure the voltage gain of a common collector amplifier in the Proteus software. Okay, in this experiment, the following components are required: transistor and power supply, function generator, CRO, resistors, and some capacitors. Okay, now before going to this experiment, I would like to explain how to open this Proteus 8 professional software. Okay, first create one folder in this main folder. Folder name is CC amplifier. Okay, this is very important for every beginner or student. Okay, double click on Proteus 8 professional as shown in here. Okay, click on this new project. Click on this new project. See, click on this new project. Okay, it will take some time. Then browse the respective folder, whatever you created previously. This is EDC experiments in this CC amplifier. Then select folder. This is very important. And here you can write the experiment name before the dot. Okay, see, observe here, CC underscore amplifier. Okay, now go to next. Okay, finish. Okay, this is our schematic capture window. In this schematic capture, you have to place the required components. Please go to the respective experiment circuit diagram. Okay, this is our circuit diagram. In the circuit diagram, the main important component and heart of the circuit diagram is the transistor, that is BC107, and resistors and capacitors. Okay, this is the function generator and this is CRO. These two is also important. So first of all, I will go to components. So click here, this component mode. See, observe closely. You can zoom your channel, your video. This is the component mode. Then go to this P. Okay, then go to this PC. Then write here BC107. Okay, readily available here. Then click on this bipolar silicon NPN low power bipolar transistor. Then click OK. Okay, then this is main library to sub library. See, observe here BC107. Then go to another component, resistor. Very simple, RESISTOR resistor. Okay, then scroll down, resistor, scroll down. So this is the resistor component. Okay, then I want capacitor also, capacitor, ELEC, electrolyzed capacitor, or ELEC capacitor, both are same, no problem. ELEC CAP. Okay, ELEC CAP electrolyzed capacitors, it's already available here. Okay, ELEC, or you can search any component, no issue. See, capacitor, electrolyzed. Remember this name, generic generic electrolytic capacitor. Okay, cap hyphen ELEC, write somewhere. It will help you in future. Okay, okay. Then all basic components are ready. Okay, you want one more important thing is that is power supply. That is V source. Okay, V source is also very important. This is okay. Okay. Now we'll start doing the experiment. So this is our circuit diagram. So first of all, transistor. First place the transistor and two base resistors. Both are by base resistors, 47 kilo ohms, and one emitter resistor. Other one is the another source resistance, 2.2 kilo ohms. Okay. Now go to this experiment. First of all, keep the transistor here. Okay. Now, right now before going to the experiment, I can zoom little bit. Okay, it will be visible somewhat clearly. Right now it is clear. Okay, right. Okay, or else you can zoom off a little bit. Right. Then keep the resistors here. One more capacitor. Right. Then rotate this. Okay, adjust the components. Right. Uh, one second. One second. This is zoom off. I will zoom in. Okay, now it is okay, right? Now you can rotate like this capacitor, and this is okay. And then I will keep one more capacitor, resistor. This is also very important. You can placement is very important. Rotate like this. Okay, then source resistance is also important. This is the source resistance. Okay, next this is emitter resistance is also very important. Just rotate like this. Okay. I have placed all resistors. Then I will go with capacitors also. Here one more capacitor is very important. See circuit diagram. Two capacitors very important. I have placed here one capacitor. Right. Then here one more capacitor here. No problem. Here one more capacitor. Okay. That's all. Okay, then VCC, this already V source. You have to keep V source here. So V source in this V source, it is also okay. Okay, now circuit diagram is ready. Now start connecting one by one. So now you have to connect CRO and function generator also. First, this is one more important option. See, observe closely. Left side of the corner, not corner, in the middle, virtual instrumentation mode. So this is virtual instrumentation mode. Right, in this virtual instrumentation mode, click on the signal generator. Okay, you have to place this signal generator in this side, right? Okay, cool. Okay, right, perfect. Now, here oscilloscope is also important. Now, place this oscilloscope right side of the circuit diagram. Here, this is the placement. Okay. Now, function generator is also placed and CRO is also placed. Now, start wiring and start connecting. Okay, just before going to the experiment, see, observe the circuit diagram. That's all. All components are placed as per the circuit diagram. Okay, now start connecting one by one. So this is the function generator input signal given to the resistor. This resistor is again connected to the capacitor. This capacitor is connected to the base, and this resistor is connected to the VCC like this. Okay, this is connected like this. This joint is very important. This joint is also very important. Now connect like this. Okay, this is like this. Now, and one more important thing is emitter is connected to like this. Okay, now this collector is directly connected this plus VCC. Okay, that's all. Now take another important thing is here. Terminals modes is also there. Terminals mode. Click here terminals mode for connecting the ground. So this is ground. So ground is also terminals mode. In this terminals mode, connect the ground. Now click on this ground and place here. Okay, just you can place here somewhere, no problem. After placing here, some components are missing, like it will be zoom like this. Okay, now connect like this. Okay, or else you can drag like this components. Okay, take one more ground here. This is also very important. This is also ground. Now connect this capacitor one end to the emitter like this, as per the circuit diagram only. Now connect another end is channel C in the CRO. Channel C, you can also observe the input signal, connect like this in this channel A. Okay, in this oscilloscope, we have 4 channels. In regular conventional labs, we have only 2 channels. Okay, that's all. Now change the values. This is also very important. Connect to the ground. As per circuit diagram, input resistance is 2.2 kilo ohms. Just double click on this value. Just I will zoom in. Once again, I will zoom in. Okay, double click on this value. This is around 2.2 kilo ohms. Okay, then capacitance value is 10 microfarad, right? 10 microfarad, okay. Then this is 47 kilo ohms, and for double click on that value, just simply you can write 47K. Here also you can write 47K, okay, 47K. Now this emitter resistance is 1 kilo ohm, then erase this 0, then this is 1 kilo ohm. Resistance emitter capacitance is 10 microfarad. 10 microfarad. Yes, this VCC is 12 volts. See this VCC is 12 volts. Now double click here, then write replace 1 with 12, then okay. So anyway, this is the circuit. Okay, this is the circuit. I will zoom in a little bit manner. See, observe closely. This is our circuit diagram. I can adjust entire screen with the help of this option, right? So this is the circuit diagram. As per circuit diagram, I have designed a complete circuit. Okay. Now, with the help of this start and system simulate button, this is called simulation button. If you click on this run button, see, observe closely. In previous lectures, I have given clear explanation about this simulation button. And in my link, I have provided, in my description, I have provided some links. Please go through it. Okay, thank you. Now I will start simulating the circuit with the help of this run button. Okay, I think circuit is ready. No more changes here, right? I will start simulating. Now this is the simulating mode. Here, adjustments are very important. Adjustments are very important. You will get the signal, but some people, some students don't know how to observe the signal. Okay. Anyway, first of all, I would like to keep input signal is 1 volt. Okay, so this is the peak to peak 1 volt. Now, anyway, this is 1 volt, no problem. Now, I will go with the 1 kilohertz. So it's vary this frequency, right? This is the frequency 1. Then this is not 10, vary this one also. Now, keep in 1. This is the 1 kilohertz frequency. This adjustment is also very important. Okay, now, right now, yellow color is our input signal. Channel A is our input signal. Channel C is our output signal. So first observe this variation. Okay, so see, this is 0.1. You will get excellent signal 0.2, and vary this time period also. You will get some accurate signal. Okay, now you can adjust these values also. You can easily measure the input signal amplitude. Now you can count the number of boxes. 1, 2, 3, 4, 5. Yes, 5 into 0.2, 1 volt. Input signal is 1 volt, frequency is 1 kilohertz. Okay, now vary this the output signal. You can keep 0.2, no issue. You can keep this 0.2, wait some time, right? You can also adjust this one with the help of this signal. See here, number of boxes 1, 2, 3, 4, around 4.5. Okay, 4.5 into zero point 0.2, you will get 0.9 volts. Okay, so input signal is 1 volt, output signal is 0.9 volt. The gain formula is output voltage by input voltage. Output voltage is the 0.9 volts, input voltage is the 1 volt. Then finally the gain is into some 100, we can do some calculations. You will get less than 1. Common collector is almost equal to unity, but anyway, as per theoretical, it is less than 1. So this is the input signal, this is the output signal. You can give the various frequencies, but there is no more change in the output signal. There is no more change in the output signal. So that is the beauty of the common collector amplifier, is also called emitter follower. Okay, this is our input signal and output signal. In this case, there is no phase shift, that is directly 0 degrees and 60 degrees phase shift. This is also very important in the interviews. Anyway, I will come back to my original position, 1 kilohertz frequency. Okay, 1 kilohertz frequency. Now change this time period axis also. These adjustments are very, very important while doing the experiments. Okay, again, one important instruction here, after executing and compiling the circuit, don't close this function generator and this CRO. Please don't click on this cross symbol. Once if it is completed, then stop the simulation. That's all. Okay, if you close the two models, again it will not open. Then again start simulating like this. You will get the signals like this. Okay, I think it is clear. Then please go with my description. You will get some more videos. Okay. Then next classes, I will explain another experiments also in this Proteus software in a easy manner. Yes, one more important point is in this experiment, we can also measure the frequency response. Frequency response is very simple. Just you can give different frequencies from the function generator. Parallelly, you can note down the values of the output signal's amplitude. How to calculate the amplitude? Very simple. Once again, I will repeat this one. How to calculate the amplitude? First, you count the number of boxes. In regular language, number of divisions: 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5. Number of divisions are 5. Scaling factor is 0.2. Then input voltage is 1 volt. Same in the output signal also. Okay, thank you so much. Keep watching. I will explain more experiments with the help of more videos. Okay, thank you. Thank you so much. Bye.